Today's lesson, we're going to talk about sets. The set, we use braces to show the set. Where 1, 2, 3, the number 1, 2, 3, 1, 2, 3 are called elements. When it's an empty set, it means when you have no elements. You also have set builder notations. When you're using the set builder notations, you need to make sure you have such that this bar right here is read as such that, and you're going to show the variable that you're going to use for calling those elements. So it will say x such that x is the natural number less than 4, or x is less than 4. This is going to be how you're going to show set A in a set builder notations. Universal set is all the elements in the set is the universal set. The subset notation is going to be look like this, and it means that P provide that if we're talking about set A and B, then B provide that every element of A is also an element of B. That's what subset is going to be. We also have a proper subset. The notation of proper subset is look like that, and that means that set B contains at least one element that is not a member of A. And we're going to talk about this proper subset and subset more in an example so you can see the difference. And people always get confused, so we will go over the examples. Tree diagram is when tree diagrams and Venn diagram is the way of showing your sets. Especially the tree diagram will shows all the subset of the given sets. Complement is if we're talking about set A, the complement of A, set A means that when the element does not belong to A. And the notation of complement is like that. So whatever that's not A, that's going to be complement of A. The union of the two sets is the set of all elements belong to set A or set B. So unions, the notation used like that. So when we have A union B, they're talking about all the set from A and or B, all the set from A or B, and use word or. Intersections notation is going to be look like this, intersections. And they're talking about the element that's inside of A, but also at the same time had to be inside of B. So intersections. The element is on both set A and B is going to be intersections of those two sets. And if we don't have any intersections, and then we use the word and for the intersections. So if we don't have any intersections of those two sets, we call that disjoint sets. There is no commons. So when we're looking at example 1, so this example 1 is going to be making sure you understand those definitions. So the first one is asking if 6 is element of this set. Is 6 the element of this set? So what they're asking is this given set carries 6? And I see you have 6 right there. So that's going to be true. So let's say that's going to be true statement. Yes, 6 is the part of that element because you see that 6 right there. And then second one is asking, is 3 is not the element of the given set because you have cross signs right here, right? So it's saying is 3 is not an element of the set, and I don't see any 3 as an element, right? So yep, that's also true. 3 is not the element on that set. What about the third one? It said set 1, 2, 3 is equals to set 1, 2, 3, 4. Well, that's not true. It's not equals to because this set do not have 4, right? So that's not true. So we will say that's going to be false statement. So in order to make this true, you need to say it's not equals to, right? When we're looking at a D, it's a x such that x is on even integers between 5 and 10 and including those. So it will be even number. So 5 is not even, so need to start it from 6. So it will be 6, even, first even. 7 is odd, so it will be 8. And then 10, but it's a included, so it will be 10. So that set builder notation is talking about 6, 8, 10, and the other set is also 6, 8, 10, and they are equals to. So this one is going to be true statement. The E is asking if A is subset. Remember, this is the notation of subset. Does A is subset of B if A is negative 3, 0, and 2, and B is negative 3, negative 2, 0, 2, and 3. Subset means that whatever that's in the element is in the set B, right? So negative 3, 0, 2. Negative 3 here, 0 here, and 2 there. So A can be subset of B. So you will say this is the true statement. Yep, so A can be subset of B. But other word, if I do is B subset of A, then it's not going to be true. Why? Because you have more elements in B, right? Okay, so then what about F? F is asking for proper subset. This is a proper subset. They're asking if A is proper subset of B. Oh, we have missing braces. So A is 1, 2, and B is 1, 2. They're equal set. When they're equal set, they can be a subset, but then it cannot be proper subset. Proper subset means that you have to have not equals to. Remember, subset notation have equal sign underneath, so it could be equals to, but proper subset do not have that sign. So if it's equals to, then it will not be proper subset. So you will say this is the false statement. Again, proper subset cannot be equal subset. The last one, it say, what about the empty set? Is that empty set the subset of A? If your A, so this is A, is 3 and 5. So this one is going to be true. The reason is because the subset of set A start with empty set. So if I wanted to list the subset of set A, I have empty set and set with just element 3, or set with just element 5, and set with 3 and 5. So any of this set can be subset of set A. That's why this is the notation of empty set. So empty set, the same as this one right here, is going to be subset of set A. That's why it's the true statement. So then example 2 is going to talk about a little more on the subset, right? So find the number of subset of the given set. So again, if we have 1, 2, 3 as a given set, your subset is going to be starting from empty set and set with having just 1 as the element, set with having just 2 as elements, 3. So single set, any of this set can be subset of given set if we call this is set A, right? And then also having 2 elements, 1 and 2, still there, right? So 1 and this set can be subset of set A, or having a 1 and 3 can be subset of set A, or also having 2 and 3 can be subset of set A. And then I can also have the equal set, which is having all the same elements. Equal set can be also subset of the given set A. So when we're counting this, how many subset it's possible? 1, 2, 3, 4, 5, 6, 7, 8. 8 subset is possible. But then when you start having a bigger set, it's hard to write it. But then if they say find the number of the subset, you have a formula to use. So in order to find the number of the subset, you're going to use the formula of 2 to the nth exponent. What's n means? N is the number of the elements. So here you have 3 elements, 1, 2, 3. So in this case, example A, if I wanted to find the number of the subset using the formula, I'm going to say 2 to the 3rd power because I have 3 elements. This gives you 2 times 2 times 2, which is going to be 8. Remember, when I count this, I had 8 subset. And that's how you can find the number of the subset without listing all the subset, the formulas, right? This is the formulas. So if we're looking at B, what will be the number of the subset? Well, this one have 2 elements. So it will say 2 times 2, so that's going to be 4. So this one will have 4 subset. So if I wanted to list that, empty set will be one of it. Always start with empty set. The set with having just T, or set of just having a F, and set of having a T and F. So that makes it 4. And you're going to have 4 subset, right? 4. So what about the next one? Next one, you're going to have 2 to the 4th exponent, which is going to be 16 subset. You can list all the subset of it. Oh, don't forget, you always need to start it with empty set, right? If you wanted to try out this problem and wanted to see the list of the subset, you can look at the notes, class notes. But because it's 16, I'm not going to list all of them, but you can find the answer in the notes. I will also list all the subset of the set ABC. Remember, I will start with empty set, and then single set is going to be A, B, C, and then double having 2 elements, AB or AC, all the mix, right? And then also BC. and then having a 3 elements. So that's going to be all the list of the subset for the given set. The next problem is asking for complement of each set. And your union set means that the set of the total. So when you're writing this on a Venn diagram, we call this is going to be a union set. Union set include all the numbers start from 1 to 10, right? 1 to 10. And then set A is 2, 4, 6, 8, 10. Set B is 1, 2, 3. So they do have the common set. So I will draw set A and set B like this, set A and B. The common set was 2. Everything else from the set A is just on A. So it'll be 4, 6, 8, 10. And 1, 3 should be only set B. So when the number between 1 to 10 that's not in set A and B is going to be outside. So we have 1, 2, 3, 4, 5 should be outside, not including in the set A and B. 6, 7 should be also outside. And also 9, right? So that's how what union set is. Union set is all the elements they're talking about, but set A only include this, set B only include that. And if I wanted to show complement of A, that will be the notations like that, and call out all the numbers. So 1 is not set A, and 3 is not, 5 is not, and 7 and 9, right? It means that B complement is going to be all the number between 1 to 10 except 1, 2, 3, right? So it will be 4, 5, 6, 7, 8, 9, 10. That's what complement means. So at number 5, we have a union set given. And inside that union set, we have set A, set Y, and set Z. And let's see if we can find some intersections and unions. This is unions, intersections, right? And then complements. So the part A, they want you to find unions of set X and Y. So we're looking at set X and Y. Union means everything from set A plus everything from set Y. Just make sure if you have a repeating elements, you just write one time. So we have A from set X, and we have B, right? Just one time. And we have D. And number 1 and 2 and 5. So that's going to be union of set X and Y. B, we wanted to find complement of X. So everything from unions, that's not X, set X. So we cannot use A because that's X. We cannot use B because that's X. That means we have C and D. And then we cannot use 1 or 2, so it will be 3, 4, 5. What about if X complement? Unions are Y complements. Well, that means I need to know what's X complement and Y complement first. So we already found X complement right here. So now we need to find Y complement. So Y complement is going to be A, C, 2, 3, 4. So everything from union that's not y will be y complement. And finding the union of these two. So from this two set, you're going to look and find all the element that's part of A complement and Y complement. That's going to give you, starting from A, and then C, D, and 2, and then you have 3 on both set, and then 4 on the both set, and then 5, right? 5 right there. So this is going to be A complement union of Y complement. What about D? You're trying to find X union of Y intersection Z. So we know what X is. What's X? X is A, B, 1, 2. And then we wanted to find union of what's Y intersection of Z. So Y intersection of Z is from set Y and set Z. You wanted to find the common, right? Intersection means finding only the commons. So it look like you have D on a both set and 5 on a both set. That 2 is the commons. So you will have D and 5. That's going to be Y intersect Z. And now when we wanted to find the union of this two set is going to be A, B, D, 1, 2, 5. Union means everything from both set, right? Now, X complement intersection of Z. You have X complement right here, and you have a Z right there. Intersection means that you're looking for common between those two sets. So the common is going to be C and D. Look like you have C and D, and 3 and 4. And 5 even, right? 4 and 5. So that will be your intersections. So it will be C, D, and 3, 4, and 5. Okay, next problem is a little different. You have N of X unions Y. What is the N of X union Y? This means find the number of X union Y. So you don't actually need to find what that is. You need to find out how many elements is there, right? So X union Y is right here. And when you count the elements, it will be 1, 2, 3, 4, 5, 6. So solution of the number of element in X union Y is going to be 6. And that means if we wanted to find the number of elements in X complements union Y complements, X complement union Y complement is that. How many elements is there? 1, 2, 3, 4, 5, 6, 7. So the solution of that will be 7. So now, example 6, we're going to look at what kind real life problems we're going to use this set. And this is one of the examples. 2012 president's elections. Let's say we have about 100 voters. And they saying 23 men voted for Obama, 29 women voted for Obama, 26 men voted for Ramsey, and 22 women voted for Romney. And then with that information, let me write as the charts how I'm going to differentiate all that information. So that's going to be part A. So the union set is going to be 100. And then we're going to use the letter O for Obama. And then R for Ramsey. And then we have the men voters, and we're going to use the M. And then we have women voters. And we're going to use the letter W for it. It's a 23 men vote for Obama and 29 vote for women vote for Obama, and it was 26 men and 22 women for Romney. Now, the first question is asking the number of intersection of Obama, the people who vote for Obama, from only men. So from the men who vote for Obama right here, right? Just the men who vote for Obama. That's going to be 23. What about if number of voters that vote for Obama, but it's not a man? So that's going to be same as number of the voters who vote for Obama, but that's going to be woman, right? Which is going to be 29, right? And then let's see, what about the third one? Number of the voter who vote for number of the voter, that's men who vote for not Obama, which is going to be same as voting for Romney, right? That's going to be 26. And number of the last one, number of voter for not Obama, intersect, not men. That's same thing as voting for Romney, female, right? Well, female, which is going to be woman, so that will be W, right? That's going to be 22, right? And B is asking, order to, with this information, are we be able to write the Venn diagrams with O and M for Obama and Obama versus men, right? So this is going to be Venn diagrams, and one circle is for Obama and the other one is going to be men. So whenever you're trying to graph Venn diagrams, you want it to start it from inside out. So all the way inside is going to be intersection of those two. So this means the people who vote for Obama, that had to be men, right? The people who vote for Obama, that had to men is that number. So that will go to intersection of those two. And then this part right here is going to be people who vote for Obama, but it's not a man, right? That's going to be 29. So that's this part right here, only, right? So that means this part right here, right? This part right here is going to be men, but who did not vote for Obama, right? Because there should be no intersection of it. That's going to be 26, right? 26. When you add them up, let me see, what do you get when you add them up? you get 78. So out of union set, you use 78 folders. So whatever the leftover should be outside of those two circles, which is going to be 22. So that will be 22. This is the unions, right? And this is how you're going to build your Venn diagrams.